Hello there and welcome to another video. In this one we're going to be dealing with our absolute value equations again like we did in our last video. The last one was on linear though, this one is now going to be on quadratic functions. So the steps that we're going to have, they're listed right here. They're the exact same as what we did for our linear function, so I'm not going to bother reading through them. We're going to get right into our first example. So it says solve the following equations, and in number 1 we have the absolute value of x squared minus 3x, and this equals 2. So the first thing we should do is we should break up our absolute value into two parts, one where we have a positive 2 and then one where we have a negative 2. So breaking it up, I got 1 on the left side here. Here we got positive 2, and then on this side we got a negative 2. And then we're going to do the work on each side of this, and then after we're going to graph and verify. So let's start with the one on the left there first. That's just a quadratic equation. To solve quadratics, we get everything to one side. So I'm going to move the 2 over to the other side, and when it moves over, it's going to become a minus 2. So I'm going to have x squared minus 3x minus 2 equals 0. And then that we're going to try to factor. So we want to try to get a product of negative 2 and a sum of negative 3. So I'm just going to write that. Product of negative 2 and a sum of negative 3. So the only things that multiply to negative 2 are negative 2 and a 1, or a negative 1 and a 2. And neither of those add up to negative 3. So we can't actually factor this one. We have to use some other method. So what I'm going to use actually is our quadratic formula. So x equals, and then we have minus b plus or minus b squared minus 4 times a times c, all in a square root, and then all of that is being divided by 2 times an a. And remember, the a, b, and c, they just come from our quadratic up here. That's a, b, and c. So putting this in, we got minus, and then b is a minus 3, so that's minus minus 3. Then we got plus or minus, then b squared is a minus 3 squared minus 4 times a is a hidden 1, and then c is a negative 2. And then all of that is inside of a square root, and then divided by 2 times an a. And a again is a 1 because there's a hidden 1 up there in front of our x squared. So simplifying that, these two minuses, that's going to become plus 3. So I got 3 plus or minus. Inside the square root, right there, if you'd simplify all of that, you're going to get 17. So we got the square root of 17 divided by 2 times 1 is just 2. And then this, we can't actually simplify or break it down any further. So that would be our one solution. If you wanted to change it into a decimal, just for when we verify in our calculator, you could do that, but it's not necessary. Next, we're going to solve this one here on the right. So again, we'll get everything onto one side. So we got x squared minus 3x, and then when the 2 comes over, it's now positive 2. So with this one, we want to try to find a product of 2 and a sum of negative 3. So this one we actually can factor. The two terms are going to be a negative 1 and a negative 2. So this is going to break down into an x minus 1 and an x minus 2 equals 0. And then we'll take each of these, set them equal to 0, and then solve. So you're going to get x equals a 1 and x equals a 2. So those are my two solutions. Now for graphing this, we're going to have this side, that can be our y1 when we go to graph, and then this side, that can be our y2. So our y2 is quite easy. It's just the function y equals 2, which is just a horizontal line at a height of 2. So that is going to be this line right here at a height of 2. And then make sure you put your arrows on the end of it. So we'll call that one y2, and it's just the function y equals 2. To graph the function y1, we're going to use our calculator to help ourselves with that. So we can get out our calculator, and then we're going to go into y equals, and then to get the absolute value, we got to click math, and then go over to number, and then it's the first one, so option number 1. And then I can type in x squared minus 3x. So x squared minus 3x. Then click enter, and then we might as well put in our other one, so that was a 2. So we'll graph this, see what it looks like. So there's our absolute value for our quadratic. So we got that kind of W shape that we've seen before in our other video. And then this is the horizontal line, y equals 2. So I can see there's some crossing points right here. I need to figure out some points though to plot on my graph. So I'm going to click second and then graph, and that'll get me to my table. And then I want to plot some of these points that are in here in y1. So I'm just going to move this over and we're going to plot some of these points. So the first one is at 0 and 0. So that is right there, 0 and 0. Then at 1 we have 2. So over 1 we are up at 2. So that is a crossing point. So that's why it was one of the solutions. And then at 2 we have 2. So that is the point right here. At 3 we have 0. So we're back down to 0 right there. At 4 we have 4. So over 4 we are up 4. So that's 1, 2, 3, 4. So we're going to be right there. So we can plot a point. And then we're going to plot one other point. We're actually just going to go up. At -1 we're also at 4, and that's because our graph is symmetric. So we're going to draw kind of that W shape going through our points. In the middle it's going to go up a little bit above that other line like that. And then on the outside it's going to be curved pointing up. Make sure you got your arrow. Then on the other side, curved going up. Make sure you got your arrow. So I can see from the graph that we have, there's 1 crossing point there, 2, 3, 4. And if you wanted to find where those points are, you could click second, trace, and then intersect is number 5. So we can click number 5. And we're just going to do the first one. So move closest to that left point. We can click enter. And then the second curve, we're also close to the point, so we can just click enter. And then one more time for it to guess. And then we got this decimal right here. This is going to be one of these solutions. If you would find the other two in the middle here, those are the answers 1 and 2. And then if you would find where this one intersects, that's going to be this other one when you take the other sign. So all 4 of those solutions are verified. All of them are going to work. So now we can move on into question number 2. And this one we have the absolute value of x minus 5 equals x squared minus 8x plus 15. Now in the previous one, what we've always been doing is we've made whatever is on the other side of the absolute value, we've made that thing a plus and a minus. But you don't have to make that a plus or a minus. You could choose to do this one. It's just usually this has more terms in it. But if I look at this one, now this side has more terms and the absolute value here only has 2. So what I'm going to do is I'm actually going to make this one be my plus or minus. So I'm going to do one equation where we have the plus. That's the first one I have written there. And then the second one, I took this and I put a minus in front. And then this right side, it just stays the exact same. You can't do plus or minus on both sides. That won't work. You only do it on one side. This one's plus, this one's minus. So let's solve that first one there. This is again quadratic, so we're going to move all of our terms onto one side. So to do that, I'm going to minus an x and add a 5, and then we'll do that on the other side, minus an x, add a 5. These are going to cancel on the left side, so we have nothing over there, and then on the right we have x squared, and then minus 8x minus x, that is minus 9x, and then plus 15 plus 5, that's plus 20. So we're going to have to try to get a product of 20 and a sum of negative 9. And the two numbers that'll do that are a negative 4 and a negative 5. So we can break it apart into those two terms. So we got x minus 4 and then an x minus 5. And then you'd take each of those, set them equal to 0, but we're going to get x equals 4 and x equals a 5. So we've got two solutions there. Next we can do the other one where we chose to do the negative. So again, with that negative, we're going to have to distribute that into our brackets. So it's going to become negative x and then a plus 5 equals x squared minus 8x plus a 15. And then again, this is quadratic, so move all your terms onto one side. So you'll add an x to get rid of that, and minus a 5, and then do that on the other side. Add an x, minus a 5. So these on the left will cancel out, and then we have nothing on the left, and on the right we got x squared minus, and then 8x plus an x, that's minus 7x, and then plus 15 minus 5, that's just plus 10. So here we got to try to get a product of 10 and a sum of negative 7. And the two numbers that'll work for that are a -5 and a -2. So again, just break this apart. X minus 5 and x minus 2. Take each of those brackets, set them equal to 0, and we'll get x equals 5 and x equals 2. And we can see one of those solutions actually repeats. So let's box our answer. Now to verify and graph this, we're going to make this side, we can call that one y1, and then we'll call this side y2. So let's get out our calculator. We'll go back into our y equals, so we can clear everything that we had in here. Need the absolute value, so I got to go back, go to my number, get my absolute value, that was number 1, and then put in x minus 5. So x minus 5. Click enter, and then just type in this one. Okay, and then once we have that, we can click graph. So there's the absolute value function. It's actually linear in this case. This part is linear. This part here is quadratic though, so we're going to get a parabola. So we got that kind of horseshoe looking shape. And I can see it looks like it crosses once there, and then we might get one other crossing point there. So to graph this on our graph, first let's find some points. So we're going to click second, graph. That'll get us to our table of values, and we're going to plot some of these points. So let's graph y1 here first. At -1, it's at 6. So -1, we're up here at 6. Then at 0, we're at 5. And then at 1, we're at 4. And it just keeps going down. You can see it gets down to at 5, we're at 0. And then to get some other points, I'll just scroll. At 6 it goes 1, 7 it goes 2, it just goes back up. Remember, because all of the points that were going to go negative, they get flipped up into the positive. So I can draw my lines going through those points. And then to graph y2, I'm going to just go back up starting at -1. So -1 is 24, that's off our graph. 0 is 15, that's off of our graph. 1 is at 8, that's at the very top. So at 1 over, we are up at 8, that is right there. Then at 2, we are at 3. So 2 over, we're actually at 3, which is the same point as the other graph. That's right here. And then 3, we're at 0, so we are right here. And then for 4, we're at -1, so 4 is -1. And then you can see 5 is at 0, so again, we're repeating another point, so we are right here. And then I'm going to have to scroll down to see some more points. At 6, we're at 3, so we can plot that. 6 over, we are up at 3, so that is right there. And we'll do one more point. At 7, we are at 8. So 7 over, we're up at the very top, we're up at 8. So now that I have that, I can draw my parabola going through those points right there. So I've gotten my graph, now I just want to verify the solutions that I had. So I'll go back to my graph, and let's find some intersection points. So I'm going to zoom in on this first. So I'm going to click zoom, and then option number 2, in, and I'm going to move my cursor. You can see it's right here right now. I'm going to move over so that it's kind of centered where all of the action is on my graph, so I can see this one, and I can hopefully see that one. So I'll click enter, it'll zoom in. And then I can see my crossing points. So there's one here. So let's find that one first. We'll go second, trace, and we want to find the intersect. So that's number 5. And then scroll over closest to the line. You can hold it and then click enter, enter, and it's going to move from these 2 points and find the closest intersection, which is right there. So click enter. And we get x equals 2. So that is one of the solutions that we had. So let's just move this over and let's put a little check mark beside our one solution. We verified that one. And then let's find where this other intersection is. So go second, trace, option number 5. You're going to scroll over to the left, so you can just hold it down. And then we're close to the point, so we can click enter, enter, enter. And then it finds our other point, which we get 5. So that is our other one here, which we actually had repeated twice. We only need to list it once in our final solution. And then just to make sure there isn't another solution here, what you should do is move over here and approach the solution from this side. So we'll click second, trace, and then number 5, and then move over to the right hand side of it, and then click enter, and then you can see it's going to search from these 2 points moving this way, and it's going to try to find where they intersect. And again, we get the same thing. So our two answers that we get are 5 and 2. So the 4 we actually have to say is extraneous and cross it out. So our final solution, let's just write that here at the end. It's going to be x is equal to a 5 and a 2. So that was our last question. Textbook questions down here at the bottom, we just got 2, and they're on page 389.